All right, on page 403 today, we are going to talk about parallelograms. And a parallelogram moving forward, we'll just call it a p-gram. Is a quadrilateral. With both pairs of opposite sides parallel. And parallelograms have some special properties. And we're going to get those in your notes now. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. If a quadrilateral is a p-gram, here are a whole clump of rules that are true. Opposite sides are congruent. So if a picture of it would look like parallelogram. ABCD. Opposite sides are congruent, so AD is going to be congruent to BC, and AB is going to be congruent to DC. All right, top's congruent to the bottom. Left side is congruent to the right side. Next, we have opposite angles are congruent. Which means that angle A is congruent to angle C, and angle B is congruent to angle D. Opposite sides are congruent, opposite angles are congruent. So here's our arc mark, and our other arc mark for angles A and C. And then on angle D and angle B, we go with two arc marks. the third rule that applies to parallelograms consecutive angles are supplementary. Consecutive angles. So looking at that shape that I just kind of reduced. Consecutive angles, if you start with any angle in this shape, and then you either go clockwise to the next angle or counterclockwise to the next angle, the adjacent angle is consecutive. Meaning if I start at angle A, and I go clockwise plus angle B is equal to 180. Angle A and angle B are called consecutive angles. Okay? If we go counterclockwise from angle A plus angle D equals 180. All right? And hopefully that makes some sense to you, because look, if A plus B equals 180 and B and D are congruent, then doesn't A plus D have to equal 180? Okay? See the logic there? Another pair of consecutive angles would be like C and D. So angle C plus angle D equals 180. And since D and B are the same theory holds true that angle C plus angle B equals 180 as well. And one more rule, well, just another rule actually. If one angle is 90 degrees, then all angles are 90 degrees. And that kind of holds true for a couple of the reasons that we just listed. If you've got a parallelogram and you're either told that the shape is a parallelogram, you know, another way to be told that this is a parallelogram is if you've got these arrows. If the top's parallel to the bottom and the left side is parallel to the right side, then you've got a shape that's a parallelogram. If one angle is 90 degrees, then all angles are 90 degrees. So if this shape has these same vertices, A, B, C, D, then look, if we make angle D 90 degrees, by the rule opposite angles are congruent, then B has to be 90 degrees. And if angle D is 90 degrees, by the rule that states consecutive angles are supplementary, well, if D is 90, then A has to be 90 as well, because they sum 180. And then back to opposite angles are congruent. If angle A is 90, then angle C is also 90. All right, two more rules related to parallelograms. There's a lot going on here. Diagonals bisect each other. Diagonals of a parallelogram bisect each other. So if we've got this parallelogram, again, all right, diagonals connect non-consecutive vertices. So D to B is one diagonal, and A to C is another diagonal. If we label the point where the two diagonals intersect as point E, if diagonals bisect each other, then A to E is congruent to E to C. Same with this other diagonal, then D to E would be congruent to E to B. All right, and finally, each diagonal separates the p-gram into two congruent triangles. Diagonals separate the parallelogram into two congruent triangles. So back to this same diagram, if we've got this parallelogram, A, B, C, D, and we add a diagonal. So if we add in DB, all right, and we're going to apply some of the rules that we've written down. In this parallelogram now, AD is congruent to BC because opposite sides are congruent. AB is congruent to DC for the same reason, opposite sides are congruent. And then look at this diagonal DB. DB is the third side of both of these triangles, so it's congruent to itself. So if we had to write a congruence statement in order to solve an equation to find some side lengths or to solve for a variable, we could say that triangle DAB is congruent to triangle. Now look where we went here. We went DAB. So we started at D, we went to A, so we went across the side with one tick mark. That means when we start naming the second triangle, we got to start at point B, and we got to go across the first tick mark down to C. So B, C, D. All right, those two triangles are congruent to each other. All right, so on page 45, we've got example 2. And I'm going to draw that diagram, QRST, label it, and then we're going to solve for some variables. So this is example 2. We've got this parallelogram. QRS and T. Both diagonals are in there. The diagonals intersect at P. And all kinds of dimensions now. So we got a left side that's equal to 5x and a right side that's equal to 27. Let's see, angle RQP is equal to 33 degrees. And angle TSQ is equal to 3Z degrees. T to P is 2y minus 5. And P to R is y plus 4. Question is, if QRST is a parallelogram, find the value of the indicated variable. We're going to find all the variables, solve for all the variables. So we're going to start with the x's. Left side is congruent to the right side. So 5x is equal to 27. And divide both sides by 5. X is equal to 27 divided by 5. 5.4. All right, next, diagonals bisect each other. If the diagonals bisect each other, then T to P is congruent to P to R. So we write another equation, 2y minus 5 is equal to y plus 4. Subtract y from each side. So y plus 5 is equal to 4. And then subtract 5 from each side. Oh, that I brought down a positive 5, didn't I? Apologize. So let's bring down a negative 5. So we have y minus 5 equals 4, and then we add 5 to each side. So our y is actually equal to 9. All right, and then finally we have z to solve for. And we know that opposite angles are congruent. So this big angle up here is congruent to this big angle down here. The other thing that we know is if you look at QT and RS, okay? QT and RS, they're parallel to each other, aren't they? And then this diagonal, QS, actually becomes a transversal. It's harder to see because everything stops at these vertices, but QS is actually a transversal. And this 33-degree angle and this angle that measures 3Z are alternate interior angles. So those two angles are congruent to each other. So 3Z is equal to 33. And we can divide each side by 3. And our Z is equal to 11. All right, so those are all the rules that are related to parallelograms. And when you're doing your practice today, just look at the given information and then apply the rule based on the information that you're given. All right, if you're solving for side lengths, opposite sides are congruent. If you have diagonals, diagonals bisect each other. So the little pieces inside the parallelogram are congruent to each other. They're not all equal to each other, but in each diagonal, the two smaller pieces are equal to each other. All right, so your practice for today is going to be on page 407. Two through 5. 9 to 12. And 15 through 20.